All right, it's your boy, the Canologist, and we're going to be doing the final easy Leetcode for this playlist. Then I'll be moving on to the mediums. Everyone's been anxiously waiting for that, so I will be doing that. And then the hards. So, let us commence this wonderful challenge. All right. Relative ranks. If you're given an integer array score size n, where score I is the ith score of the ith athlete in a competition, all the scores guaranteed to be unique. Okay, that's athletes are placed based on their scores. Okay. Where the first athlete plays the highest score, second highest score, and so on. Their rank is their placement number. Return an array of answer size n where answer I is the rank of the ith athlete. Okay, so the first three highest scores are basically this. Then we get 10-3. Okay, so I guess the first thing I'm going to do is make a pass through the array. Since everything is unique, what I need to do is first list out everything. So for score, so self score is the input array. So I'm gonna go sorted score equals score dot sort. So that gives me from lowest to highest And then I'll go gold, silver, bronze. So then I'll create a what's called, it's sorted now. Now I could just create a dictionary. Of the value. So now I want to go it's going to be counter 3. What's the size of n? N can be 1. So I got everything sorted, so it's going from lowest to greatest. Let's go to the whiteboard. Lowest to greatest. Then I want to reverse it. I want to go from this greatest to lowest. Because once I have that, I could order it from gold, silver, bronze, 4, 5, 6, all the way up to N. Score.sort, then that. So I reverse it. And then I create a dictionary. It's called stores, where I put this key value pairing. For I in sorted scores. This goes from lowest to greatest. Now it's going from greatest to lowest because I flipped it. in range. It's gonna be for I in range. Sorted scores, score.sort I. Yeah, and then reverse it. So for I in range thing, if I equals 0, let's call it stores sort. So if I equals 0, stores I plus 1. So 0 length stores, right? Because it's a 0 indexed array, but I'm going to make stores I plus 1, which is what I'm putting in the dictionary, equal to gold medal. And then it's going to be elif I equals 1, because there's special privileges. So I plus 1 silver medal. And then the third one, 0, 1, 2 elif. They're all unique, so I didn't need to worry about repeats. So I because the placings go first to fifth, right, on these, but the array starts at 0, so I have to do it I plus 1 as the entry. Then I just reference the value and return the key to get the placing. All the values are unique, which makes it easier. All the scores are guaranteed to be unique, so this makes it easier. So for I plus 1 equals bronze medal, else Oh no, for I equals 0. Yeah, gold, silver, bronze. And then stores I plus 1. Sorted score. Sorted score. I sort all the scores or reverse them. Stores. Okay, so then I could put. I don't need to reference this. I could reference the values. I could just reference the values. So instead of doing positions, I could reference the values because it's all unique. So if I equals 0, I could just go like this. Scores I, and then just search up the value and the ranking comes beside it. So I go stores, the key is gonna be their score, their actual score. So sorted score, I. Yes, this is what I'm trying to aim for. Boom. Sorted scores I. Boom. Sorted scores I. So for 0, 1, 2, for these specific places, I want it to be this. Right? For anything greater than that, I still want it to be sorted scores I. But now I'm going to give it a ranking. And it's going to be I plus 1. Because it's placing, not an index of the array. So this should give me a dictionary of every score, and I can reference the score to get their ranking. So if it's 99, this is the gold medalist. 98, this is the silver. 97, this is the bronze. Right? So now that I have this, I can go and compare my array to the dictionary. So for, let's create an output array. For item in scores. So as it comes up, so let's say 5, I'm going to go dictionary. So output dot append stores dot item, stores, and then I'm going to reference the value. So stores at this value. Stores at the item. Instant lookup time, because I could just directly reference whatever my key is if I know the keys. And then I just return the output, and that should be it. But let's walk through it. So if I get 5, so basically what I did here was I get a I get the rules, right? The only exception to these rules are the first three rankings: gold, silver, bronze. So if I get the top three scores, 5, 4, 3, there should be gold medal, silver medal, bronze medal. The rest should be the placings after. So then the next placing should be 4 and 5. 4 and 5 are the lower scores. So the higher the score, the higher the likelihood of a medal. So the top three scores get the medals, and then the rest get their placements. Alright, so what I did was I created an array, I sorted the scores array. So I go from lowest to highest. I flip it. So that way I get the highest to lowest, right? And now I just go through it. And I create a dictionary to map the highest value, the highest score to its ranking, right? So, and then I added in the rules. The first three rankings that are the highest get the medals: gold, silver, bronze. The rest get their placements, I+1, right? Because it's a zero indexed array. So gold, silver, bronze will be 0, 1, 2, right? And then the next placing after that is fourth place, because bronze is third place. So I have to go I+1 on the 3 to get a 4. So then, let's see. String up, and then I have to turn this into a string. There we go. Because this is a number, or I could just typecast it here. Doesn't hurt. There we go. I can just do it directly. And then, so what happens is, we can walk through this example before I submit and run. We get 5, the highest score. This is all in order from highest to lowest. So this should be gold, 4, silver, 3, bronze, 2 is 4, because after bronze is 4th place, and then 1 is 5th place. Okay, now we have a jumbled up one, right? So now we go 10. I go to my dictionary. It's going to go 4 item and scores, so it's going to go 10 first. So 10 in scores is the highest level. Highest level is gold medal. Boom. 3, right? So 8. So 9, 8 are the other two highest, and then 3, 4. So 3 is in the last. So that should be 5th. So it's going to go 3. Stores item at 3. It's going to go into the dictionary. So 3 places to 5th in the sorted array. So you get 5th place. And then you get bronze, silver, and 4. So let's run it. What? Oh, because there's edge cases. Okay, so none type has no attribute. Score.sort. I'm just curious. Is that an error? All the values in the score are unique. N equals score.length. N equals score.length. Okay, cool. Length score 0 to N. Scores can be 0. 10 to the 6, okay. Scores could be, score I is 0. Score I can be 0. N is 1 element. So N is the score length. You can have a minimum 1 element, so. Score.sort. score dot sorted score I. Sorted score I equals str plus 1. None type has no len. Object of none type has no len. Output item append. Okay, so I want to reverse this. None type has no attribute reverse. What does it mean by none type? Oh, I know why. I know why this is happening. Okay. Okay. Sorted score equals score. It returns a none type. You have to make a copy of it. Sorted score. Sorted underscore score dot sort. You do this outside, and then you go. Scores is not defined. Scores is not defined. Scores. Where is that? Item score. Dot reverse Python. I just want to make sure I'm doing it the right way. This should solve it. So you can't actually put it in here. So you have to use fruits.reverse. Same use fruits.sort. You don't return it to a variable, because if you return to a variable, you get none. You have to. It just operates on itself. It's a built-in function. List.reverse, no parameters. You see, you can't return. You don't return a type. So you have to go dot sort dot reverse, right? That should work. What? Gold, silver. Oh, I spelled silver wrong. That's why. That should work. Five. Silver medal, bronze medal. I equals 1, so I equals 0, I equals 1. Aleph, 2. Silver medal, bronze medal, 4, 5. Where is it failing? 10, 3. Sorted score I. str plus 1. Item in score. Oh, it's item in score. It should be item in sorted score. That's why. It should be item in for item in score. Oh no, sorted score is put into stores, my dictionary. My dictionary at this value item in score should correspond. So gold medal should be the first. The second is what? 5. 3 should be 5. Why is 3 silver medal? Okay, it's looking like it's forcing it to be gold, silver, bronze. I equals 0. sorted score at 0 should be gold. At 1 should be silver. At 2 should be bronze. At 3 it should be 4. It should be 4. Maybe it's because no, but it has the values 4 and 5. It has the values 4 and 5, so why is it doing this? For item, output, append, stores, item. I'm getting the value. Len sorted score, stores, output. For item in score, so I take the value. That's my value. Stores at that value. Oh, I think I know why. I think I know why. Because sorted scores, so stores is looking for possibly a string. Let's try that. Or no. Could that be the reason? And if it is, let's figure it out. Five. str5. I equals 1, I equals 2. Equals I, the value, plus 1, key error 5. Okay, let's figure out what's wrong with it. I don't know why it's wrong, per se. Let's take the code. Let's try it. I just want to see where it's going wrong. So let's go to Python Playground. You guys already know. You guys have been here long enough. I go here every fucking time something's going on. So let's test it. Okay, sorted score, and I'll put score equals this. I want to see exactly where things are going wrong so I can debug it. Okay, so let's go here, sorted, and then output. So let's go print. Let's do print as this. This is also an indented language, so we gotta make sure everything here is properly indented. And then let's go print output. Okay, gold medal, silver, bronze, 4, 5. Okay, so then, okay, this is fine. Once we have this, once we go through this whole loop, I just want to print out my dictionary. Print out stores. Let's comment this for now. I just want to print out stores and see what's in there. So 3 is 5. 4 is 4. Bronze, silver, gold. Okay. 3 is 5. Bronze, silver, gold. 3 is 5. 3 is 5. 3 is 5. 3. 3 is 5, so it's correctly outputting in my dictionary. What's wrong? It takes the value, assigns the number, so 3 is 5. Perfect, everything's fine. What's going on? So 2, 3, 4 is 8. Three is 5, 4 is 8. So 10 is the gold medal, 9 is the silver, 8 is the bronze. 8 is the bronze, which is fine. And then 3 is 5. Ah, 3 is 5 and 4 is 4. Okay. Three should be 4. Okay, L of I equals 3 onwards, I should put. I want to make sure before I print this, I'm going to print empty. I want to print my stores. I want to print my output. What is my output? No, not my output. I want to print my sorted score array. Sorted score. 10, 9, 8, 4, 3. So this is the reversed array with everything as it should be. So 3 should be place 5. Ah, value 3. Value 3 should be place 5. Value 3 should be place 5. Yes, that's correct. Value 4 should be 4. Value 10 should be gold. Value 9 should be silver. Value 8 should be bronze. Value 4 should be 4. Yes. Value 5 should be 5. Okay, so everything's correct. Okay. Okay, now it's for item. Ten, 9, 8, 4, 3 for item and score. No. Why is score being sorted? I think that's what's throwing it off. Score is being sorted for some reason. For item in score, score should be fine. Sorted score is what I want to change. I think they're referencing the same positions. So if I want to make a duplicate array in Python. Deep copy. I think they're referencing right now. So what's happening right now that you're seeing, if you look at the outputs, I'm only touching sorted score, but the initial assumption was that sorted score is what I'm using and it's a copy of score. But what's happening is they're referencing the same position in memory. So when I apply changes to sorted score, it also applies to score. Because when I print this out, let's say I print out scores right here, right? Let's do a quick test. Print sorted score, and then print score. You see that? You see that? They're the same arrays. They're pointing to the same location in memory. So what I have to do is I have to make a deep copy, which is, so that's not really a logic error. That's more so like a syntactical bullshit error. How do you create a duplicate array? Or let's just do it the old-fashioned way, the for loop. So sorted score. Then all I have to do is this. That way it's fair, and we don't have to use any fancy tricks. We're just gonna do a for loop for item in score. Sorted score dot append. This is actually a really good way to end this, to show you guys like we can troubleshoot our steps and trace back the exact issue that goes on. Sorted score dot append item. That should work. I should properly sort everything. There we go. See, it's the deep copy issue. So what I did first to figure out why it was an issue is first I wanted to take all my code, put it in here, and then actually look at the placings. Is my code correctly assigning placings in my dictionary? If I go to dictionary, highest value is gold, second highest is silver, third highest is bronze, fourth highest is 8, fifth highest is 5. Right? Because 4 is bigger than 3, so I place higher than the 3. So 3 is the last. So if I'm getting the right placings, why am I not getting the right output? So the only reason I could think of is, okay, it's something to do with the array. So then I print out each thing. It's printing 10, 9, 8, 4, 3, but that's sorted. Score, I didn't sort score. So if I go to the very top, I sorted the sorted score array, not score. Which means that somewhere along the lines, something had an effect on the original scores array. So that would lead to tell me that this is the only position where we don't interact with score this entire thing until the end. So the issue's happening here with sorted score and score. What I wanted to do is create a duplicate of score within sorted score, so that I could just do my operations on sorted score, then reference the original array in the end. But what happens here is when you assign it this way, they don't point to this. They point to the exact same place in memory. So any change you make to the duplicate gets made to the original. So what you want to do is, the way I did it here just now, is all you have to do is create a for loop and just individually add these items to the new array. And that gives you like a new duplicated array, no event time, right? And then all the applications, as we know, works. And then we can just reference back the original array in the same positions. So 10, 3, 8, 9, 4 instead of 10, 8, 10, 9, 8, 4, 3, and then get the correct placements of the array as the output. So submitted this, it works. So then let's submit. And there you go, beats 46.55% of other solutions. We are good to go. It passes all the tests, passes the submission. And that is relative ranks. If you like this video, please give it a thumbs up. Subscribe, comment below. This is the 100th video of the Leetcode Easy playlist, and I will be now doing mediums. So stay tuned. Peace.